All right, starting off, 1.6 is complementary angles. Complementary angles are two angles that add to 90 degrees. Two angles that add to 90 degrees. Okay. Does it say that they have to be touching or connected in any way?
No.
No, it just says there are two angles that add to 90 degrees. So it could look like this. 60 degrees, 30 degrees. That's one option. That's definitely 90 degrees, right? So those two angles will be considered complementary angles. Or it could also look something like that. And they don't have to be touching. They just have to add to 90 degrees. Can there be more than two of them?
No.
No. Now, could you have more than two angles that add to 90 degrees? Yes. They're not complementary though. Okay, to be complementary, there can only be two. Our next definition, which is very similar to that one, is supplementary angles. Supplementary angles are two angles that add to 180 degrees. So what's the only difference?
It just
It's
adds to 180 instead of 90.
Adds to 180 instead of 90. This one's bigger. Okay, so again, they can be separated. So it might look like this, where this is 120 degrees and this is 60 degrees. Might look like that. Or it could look something like this. And obviously I'm just using nice round numbers. It could be like 23 and, you know. Okay, so just be aware of that. They're not always going to be that nice. Okay. Can there be more than three angles added together and call them supplementary?
No.
No. Two. Two angles that add to 180 degrees. Good so far? Okay. Third definition we have is adjacent angles. Okay. Adjacent angles are two angles next to each other sharing a vertex. So if I label these as angles 1 and 2, are those two angles adjacent to each other?
Yeah.
Yes. They share a common vertex, and they're next to each other, right? Okay. What about angles 1 and 3?
Yeah.
No.
Why not?
I'm not sharing a side.
They're not what?
Sharing a side.
One more time.
You're not sharing a side.
They're not sharing a side. They're not next to each other, right? Okay, there's something in between them, which would be angle 2, correct? Okay, so 1 and 3 are not adjacent to each other. They do share a common vertex, but they're not right next to each other. Okay? What about angles 2 and 3?
Yeah.
2 and 3 would be adjacent to each other. Okay? Good on those three definitions? Okay? So an example similar to example 1. This one's 28 degrees. This one is 72 degrees. This one's 108 degrees. And this one's 62 degrees. Okay, I'll put some numbers in here so we can talk about these angles. Okay, so I have angles 1, 2, 3, and 4. Ukiah, name a pair that would be complementary. 28 and 62. So angles 1 and 3 are complementary, right? Does everybody agree with that?
Yeah.
And he knew that because he was trying to find two that added to 90 degrees. Casey, a pair of supplementary.
108 and 72.
108 and 72, which would be 2 and 4, right? Because he's trying to get them to add to 180 for supplementary. And Jason, can you give me two angles that are adjacent to each other?
4 and 3.
4 and 3. Everybody agree? Are there any more? No. Okay. All right. Two examples here of problems you may come across with complementary and supplementary angles. Let's say they give me this with this angle, and I don't know, maybe they say this is 71 degrees. Okay, now, just looking at that diagram, is there enough information for me to think that they add to anything? No. It looks like it is probably supposed to be a right angle, but they didn't tell us, and they didn't show us, right? Okay. Now, what if they said angles 1 and 2 are complements of each other? Now do I know what they add to?
Yes.
Yeah, what do they add to now?
90.
90, because I use that word complement, right? Okay, so angle 2 would have to be 19 degrees. Now, did I ever use the word complementary? No, I just said the word complement, right? It means the same thing. Okay? If they're complements of each other, then they are complementary angles. So they add to 90. Okay? Could we handle a problem like that? Okay. Now the next problem that they're going to look at, in your problem, they're actually talking about soccer goal. Hey, you guys have seen soccer goals. They angle up and then they come down, right? If I'm looking at it from the side.
Yeah.
Okay. They're wanting to know if this angle here is 7x plus 13 degrees. And this angle over here is 25x plus 7 degrees. They want to know, what are the two angle measures? We have to know a little bit of information before you can solve this. What else do we know about this diagram? Why do they have to add to 180? Because it's a straight line. There was one thing I told you can assume in geometry at this point. What was it? If it looks like a straight line, then it is a straight line, right? So am I okay without them telling me that this is a straight line or that these two add to 180? Am I okay assuming that it is? Yes, that's the one thing you can assume right now. So, since we know that's a straight line, Ukiah was telling us they have to add to 180, right? Well, if you're telling me they have to add to 180, then you should probably set up an equation, adding them together, and setting them equal to 180. Okay? By doing this, am I going to immediately figure out the angle measures?
No.
No, I'm first going to do what, Jersey?
Solve for x.
Solve for x. So 25 and 7 is
32.
32x. 7 and 13 is 20 equals 180. Subtract your 20, you get 32x equals 160. So x must equal, bless you,
I'll have a walking pass on you, but she's good and we'll take care of it.
okay, sounds good, thank you.
You're welcome. These kids.
Good bunch.
They are.
Good class.
They are. I can't give them a hard time, I feel bad.
Thank you. Okay,
Yeah.
it's what?
It's 5.
It's 5, yep. Okay, so x is 5. Now that I know that, I should do what then to find my angle measures?
Put 5 in.
That's put 5 in for x. 25 times 5 is? 5 quarters. 125 plus 7?
132.
132 degrees. And they would probably label that angle, and you'd have to say angle at 1 equals 132. Okay, but I didn't, so I'm just going to list them here. Now, first period did make the comment, and they are correct partly. They said I can now take 180 minus 132 and get my other angle. True. I'm going to recommend that you don't do that. Does anybody know why? It's just a recommendation. It should work usually, but why might it not always work? Nothing? What if you got this wrong? What if you accidentally copied this down wrong, and you accidentally added wrong? Then what happens? Then you're going to miss the next one too, right? Now, if you're right, the other one's probably going to be right also. Okay? I would recommend to you, and take it for what it's worth, it's your choice, I'm not going to make you do it. I would recommend you take the 2 extra seconds it's going to take to plug that in there and solve it that way. Because if I miss this one and then use it and miss them both, I get 0. But if I miss this one and plug in here and get this one right, I'm getting half that point on my test. Okay? Like I said, it's up to you. I'm not going to force you to do one way or the other. Entirely up to you. Okay? But in geometry, we're going to try not to use things that we found, and we're going to try to use just their information most of the time. So I would take 5, 7 times 5 is 35, plus 13 is
48.
48. Did that really take any longer than it would have taken to do the other way? No. And I know I'm right. Now, we got the first one right this time. And you will probably most of the time. Okay, but like I said, if you happen to miss the first one and then use it, you're guaranteed to miss the second one. Okay? We handle that. That problem's not too bad, right? Okay, so flipping the page, we have 2 more definitions to look at. The first one is a linear pair. Now, before I even tell you the definition of a linear pair, just breaking down those words, what do you see in there?
Line.
Line and
2. Pair.
So 2.
a pair. So you know 2. You know you're going to have 2 things, and you know you're going to have a line, right? Okay? Well, we're talking about angles. So a linear pair is 2 angles that form what? A line. And that's not their exact definition of it, okay, but that seems to be the easiest way for students to remember it. 2 angles that form a line. Okay? So, if I draw 2 angles up here, are 1 and 2 a linear pair? Did they make a line? They didn't, right? That's not a linear pair. What about now?
Yeah.
See the line they made? Right here. Okay? So, are they very similar to supplementary angles then? Yes. The only difference is, the main difference, is a linear pair cannot look like this. That's not a linear pair. They're supplementary, because they're not touching. Is this a linear pair?
Yes.
Yes. Okay, so it's just a little more specific. Okay. So, knowing that that is true, what would angles 1 and 2 add to? 180 degrees. Okay. The last term, and one that sometimes takes students a little while to figure out or to understand, vertical angles. Okay. I'm not going to write a definition for this one because in the past I've found that students like to think about it differently than the book tells them. Okay. I'll just show you, I think. Once you figure out vertical angles, you're never going to forget them. Okay? The way I've found that most students like to remember it is they're directly across from each other or opposite of each other. Okay? 2 and 4. See how they're directly opposite and across from each other? Those are vertical angles. Now the way the book says it in the technical definition says it's 2 angles at the same vertex that form 2 pairs of opposite rays. Okay? So I'm looking for 2 pairs of opposite rays. Well, there's 1 pair of opposite rays, right? Here's another pair of opposite rays. Okay, 2 and 4 just formed 2 pairs of opposite rays. If you want to think about it like that, that's fine. Okay, I don't care how you think about it as long as you understand. Okay, I'm going to erase that. So if that's true, Bo, what's one more pair of vertical angles besides 2 and 4?
1 and 3.
1 and 3. Okay, those are our pairs of vertical angles in that diagram. Does anybody see a linear pair?
In 2 and 3 and 1 and 4.
2 and 3, 1 and 4,
1 and 2 and 4
1 and 2 and 4 and 3.
1 and 2.
1 and 2, 4 and 3. Okay, lots of pairs, lots of linear pairs in that diagram. Right? You okay with those 2 definitions? Yeah, I got 2 more examples for you, and then I'll let you work on your assignment. I just got all this. This isn't in your book. Just making this one up. I have angles 1, 2, 3, 4, and 5. Raise your hand if you can name a pair of vertical angles. What do you think, Paul? 2 and 5. 2 and 5. Does everybody agree?
Mm-hmm.
Angle 2 and angle 5. Vertical angles. Are there any more?
1 and 4?
There'd be like, 4 and 1.
Okay, so here's the catch with 4 and 1. And the one way you can look at this is they don't look like they're the same, right?
Mm-hmm.
Notice on all these vertical angles that we've done so far, they look like they're about the same measure, right? 1 and 4 are not. Now, let's check using the book's definition. Do they form 2 pairs of opposite rays? Well, there's 1, right? But are those opposite rays? No. So do you still think 1 and 4?
No.
Does anybody see any others?
3
Okay.
and 5.
3 and 5, okay? Do they form 2 pairs of opposite rays?
Mm-hmm.
No. Do we still think 2 and 5? No? Are there any more then?
No.
Yeah.
No, there are not. Now here's another way to think about it. A little trick. When you get your diagram, you see a bunch of, hopefully you think lines and rays. Okay? Find the ray. here's the ray, right? Agreed? That's the ray. These other ones, at least to me, I see lines. They go all the way through. You guys see that? If it's touching the ray, you can't use it as a vertical angle. Okay? There's nothing opposite of 3. There's nothing opposite of 4. Okay? Meaning, that automatically takes out angle 1, right? Okay? So the only ones that are formed by 2 lines are 2 and 5. So if it's not formed by a line, you can't use it. Okay? Casey, actually I already called you. Dylan, you see a linear pair. 2 angles that form a line.
Yeah.
No. Give me a pair. That looks like they form a line. 2 angles.
3 and 5.
3 and 5. Now, 3 and 5 are on the same line, but wouldn't they need 4 also?
Yeah.
So give me just 2 that make a line.
2 and 4.
Would 2 and 4 need 3?
1 and 5.
There you go. So a linear pair would be angle 1 and angle 5. I'm glad he showed us these other ones because 3 and 5, they are on the same line, right? But in the middle or between them, you have angle 4 also. Okay? Is there one more linear pair?
Yeah.
4 and 5.
1 and 2. Why not 4 and 5?
Because it also
They don't form a line, right? Okay, so just be careful with that. They don't form a line. True or false, 3, 4, and 5 together do add to 180.
True.
True. Okay, but they're not a linear pair and they're not supplementary because there's 3 of them, right? Okay. One more example, and this is an example that sometimes confuses people. I gotta think how they word the problem. 2 angles are a linear pair. One angle is 8 times larger than the other. You guys done problems like this before? I think you probably have similar problems at least. Find the 2 angle measures. What words out of this problem are probably very important to us?
Linear pair.
Linear pair, that's probably the first really important thing we see. What do we know about a linear pair?
Make line.
They make a line, and there's 2 angles, right? So, regardless of what the rest of it says, since they are a linear pair, I know they have to look something like that, right? Maybe this ray could be anywhere, but they're going to look something like this. They're going to form a line. Okay? What else?
8 times larger.
8 times larger. So one of my angles is 8 times larger than the other. The challenge is here, I don't know what the other angle measure is, right? If I told you the angle measure was 20, you could easily take 8 times 20 and you'd be done, right? Okay? And they're going to be harder than this sometimes. Sometimes they're going to say one angle is 12 degrees more than twice as much. Okay? And I'll explain that here in a second. But what you're going to do is we are going to go after the other angle first. It doesn't matter which one you think it is. Just pick one of the angles. I don't know what it is. I don't know the measure, so I'm going to call it X. Because it's unknown, right? But what do you know about this angle?
8 times larger than that.
It's 8 times bigger than this, right? Which means it must be 8x degrees. Now I have an equation because I know that these 2 things together should add up to
180.
180. So I know that 8x plus x is 180. 9x equals 180. So x must be
Done. Or 20, yeah.
20. Okay, so this angle measure is
20.
20 degrees. This one is
160.
160 degrees. Okay. Remember how I made the comment about 12 degrees more than, okay? Let's say it's 15 degrees more than 3 times as much. Okay? So in here, it would be 3 times as much, but it'd be 15 more than that. Okay? And then what would you do with 3x plus 15 and x? Add them together, set it equal to 180, right? Okay, I'm going to go back on this just so it's back to the original and makes sense with the work. Okay, but understand you will have problems similar, a little bit more difficult to this. Okay? Questions on our 5 definitions from today? Okay, remember our next class period we will do our practice test. The class period following we will do our actual chapter test. Okay?